There's a lot of misconceptions out there about using Booleans when creating 3D models, so we're going to talk a little bit about it in this video. And when you're browsing the web, you're going to find this on forums and comment sections all the time that people say, don't use Boolean Ingon workflow because it creates trash geometry. And in some respects, that's true. It does, create more difficult geometry to work with, perhaps. But one of the things you're going to realize very fast when you start looking at how professionals work with 3D modeling software is that Boolean Ingon is just really a technique. It's a tool in your tool bag on how you can actually create 3D models. And once you realize like the different ways of processing geometry, whether you're going to end up with like a subdivision mesh or you're going to try to use like a remesh workflow, all the various different techniques, other techniques you might utilize, Booleans are just part of the process usually, right? And so it's really important to understand that workflow in general is not that it's bad by itself. It's just that when you don't know what you're doing with topology, that's when it becomes bad, right? A lot of times you have to have your Boolean shapes kind of line up with your geometry in order to turn them into subdivision models. But there's also other ways of turning models into subdivision models. And depending on your use case, it's also going to dictate what you end up doing. Because like, what is trash topology? Well, it depends on who you ask and what they're doing. Because if you're working in like product viz or maybe VFX or something like that, or on characters, quad topology, minimal n-gons, triangles, n-poles, e-poles, and mostly quads is very highly desirable. Evenly spaced mesh, all that fun stuff, right? So it deforms really well and whatnot. When you're creating game models and your only object is to create a really good looking model that shades well enough, you can work with Boolean Ingon, convert it into subdivision, and then you can take that model and bake it to a low poly later on. And often for game artists, they understand the modeling techniques the best because generally they're trying to do something like create a high poly and a low poly at the same time. You create more or less something like a mid poly where you can work it out in both directions. But that doesn't always work out either. You see like character artists oftentimes just start with the sculpting process and they kind of throw topology to the side and later on they have to go through the retopology process, right? So there's always like a trick to everything. Like you can kind of do a mid poly and work it out in both directions. You can do high poly, retopo it. Whether it's hard surface or characters, it doesn't matter. Even when you're creating low poly models, if you have a really awesome high poly already made, you can retopo that thing. And retopo doesn't always look like retopo. Sometimes you're just making parts that fit with the high poly. So you might be doing more Booleans on parts to match it and anything or like that anyway. So in this example here, and we'll just kind of jump through it real quick. I started with this shape, right? Like this is like the simplest shape, and I created a non-destructive cylinder. Okay, non-destructive cylinders I've shown in previous videos, but basically it's a vertex set up with a screw modifier, and I took it a little bit further when I got over to here. You can see these are all Boolean together now, but basically you can add a bevel, vertex group bevel on these edges or these vertices here. Okay, so you have to set it to vertices as well. But this gives us the ability to do things that are non-destructive, right? So when we're using that Boolean Ingon workflow, we now have all these different shapes, but if they're all kept as non-destructive as possible, we can always tweak the counts here later on. So any one of these shapes now, if I go run through them, you can see like the front side here, I can change the segment counts on the screw modifier, for example. And we have a non-destructive cylinder, but that bevel even on it, because of the way we did that, well, now we can change the offset, for example, or the counts as well, right? So we can tweak it. So basically what we end up with is a model that we can literally have a starting off point for a low poly or high poly, and it matches for the most part, right? Even if this base mesh was like subdivided, you see what's going on here? Control 1 through 5, when you have a subdivision modifier, it'll change the viewport level. If I need more curvature, I can do that. Okay? So you can't do this, as far as I'm concerned, in any other way inside of Blender. Like you have to go through this process of learning how to use Boolean Ingon workflow in this manner, in combination with subdivision mesh, potentially, if you want to start with like a sub D base, so you can work things out like that potentially. Now, so you might bump up all your resolution, however you see fit. You might end up with a shape like this. I duplicate the base of it maybe and convert it to a mesh. And you can start processing this in any number of different ways. So like If you can get away with something like a bevel on it, maybe you bevel it. In our case, we can't right now. We'd have to clean it up perhaps, right? Or maybe we could use an add-on. Maybe we could use like a mesh machine and we can do the experimental offset cut feature. And we can add some bevels in here like this. So we do that. We hit Control B now, and we can bevel out, hit C to clamp it perhaps, or hit M a few times. We could do a percentage bevel out to those corners. Boom. Like that. And we can, clean it up, merge all by distance. And so, we could do things like this potentially. Now, why would that might be important? That's the real question you're probably going to ask yourself. Like, what is the point of doing this like this, maybe? And so here's the trick. If we are planning on using something like the remesh workflow, where we're not using like a quad remesher, but just regular remeshes, what you would do is at some point, and a lot of people are using this workflow for game models, by the way, where they create an undestructive mesh and they remesh it. So like just say, I'm going to do a 0.05, well, maybe a little bit more, let's do 0.01 remesh. Oh, too much. It's actually better to go higher, but while I'm recording, I don't want to. So let's just say we remesh it, right? If we didn't have enough segments, so it gets too faceted, no matter what we do here, it wouldn't work out. But basically, you would smooth shade it, and then you would add a smooth modifier and smooth it out as much as you need to get rid of the faceting. And so you could end up with a high poly model this way. Not a big deal. And you know what's even fun about this? Don't decimate it right away. You can convert it to a mesh. And a lot of times it's still fairly usable to sculpt on potentially, right? So like you could try to even add some little scrapes and stuff and whatnot inside of this mesh. Although voxels get a little bit squirrely sometimes, and you might want to try remeshing it again later on perhaps, but it's just something you can do. And it's not something that's as common of a knowledge, I would say, for a lot of Blender artists. And it gets even crazier than this because it is it's a high density mesh and we can work on it and all that fun stuff. There's add-ons where you can sculpt in layers, right? So you can non-destructively sculpt up different details on this thing in different little layers, and you can do that. And I actually have that add-on in here, so it's kind of one of those things. But let's take it another step further, right? Like maybe we just want to try to quad remesh this. We shade it like auto smooth or something like that, or maybe we can use like a hard ops and sharpen it. And if it doesn't quite get something right, maybe we can grab some edges and mark them as sharps, right? So we can use mesh machine to select an edge, click, alt click, right? All that fun stuff. And slowly start to work this out like this, right? And once we have sharps, we can use normal splitting with quad remesher and symmetry if we need it, and we can remesh, guys. And that's how that one became a thing right there, right? So you can see this one's a little bit better because I kind of messed up on the other one, but we end up with an N-gon here, or a thing here or there. We can manually correct that very fast, much faster than we can model this ever with proper topology from the start with subdivision, right? Like we can still model it pretty fast with subdivision, but it's not going to be a couple clicks like this. And so, and then a little bit of editing afterwards. It's really important to understand that, this is just how it kind of goes, right? Like there's different techniques, there's different ways of processing after. This isn't trash mesh because there's a bunch of dirty Booleans taking effect here. No, it's not trash mesh. It's still usable if you know what you're doing. And so if I was to like initialize face sets here by normals, okay, and do this number, maybe we can break it up a little bit more carefully, right? We can manually change our face sets as well if needed. Like I don't need this many face sets in this area doing that. So maybe I just go through here, grab all that, go back to sculpt mode. And then with that selection and edit mode, I can come over here. Boom. Yep. We got a new face set. So we can manually define our face sets super fast. We can use selection methods you probably don't normally use, like select more or less with Control Underpad plus or minus, find out where you want to go to. And then, just go ahead and set your face sets from the edit mode selection, set up a shortcut for it too. It's useful. All right. And so this is just more processing that I might have to end up doing to use quad remesher. So right now we were doing normal splitting, which uses sharp edges to do it. Maybe we want to use materials, right? And so we can do that with face sets if you have the face set operator add-on, right? So you can set face sets to materials, boom. There we go. Now we can use materials to do this and go ahead and do it again. Is it going to give us a better result? Probably. Um, in this case, not really. It's not much different anyways. It's about the same. I think we could dissolve that, merge that. It's slightly better perhaps. But if we ever run into a situation where this one fails, we can try this one. If both of those fail, maybe we would revert back to using a voxel remesh where, you know, we're not worried about having quads at all. And, you know, so you just keep going with this. Like, and if both of those fail, you could take your Boolean Ingon mesh over here. You can go back and you can say, I need a certain amount of segments. You have the ability now to change any one of these however you see fit to get them to work out correctly. And that's just the way it is. Now, then you could process this manually to a subdivision mesh to whatever you need it to be. Okay, you can kind of look at it and start to figure out what you need out of this mesh, and it's the segment counts, because maybe we don't need, you know, that many pieces inside of here, right? Maybe we only need a let's say like 2. Like, and that would work better if you're going to convert it to subdivision, right? So that way you can have less stuff to do while trying to work it out, basically. You just want to be able to preserve the volume. That's it. And then, yeah, once you have a mesh like this, you can go crazy with detail if you wanted to. Like, you can take it to the next level, perhaps. It's using subdivision. Right now, here off the bat, it is. Anyways, bunch of booleans on it. Wait, oh, we had the wrong one selected. Okay, this one we're looking for. It's a multi-res, all right? So instead of using subdivision, like if we had done this, we could have done it like this, where we subdivide it, okay? You can see we subdivide it, okay? But if we add a multi-resolution modifier instead, and we turn that one on, you'll see we can actually start detailing it. If we have good enough topology, this isn't a big deal. Quad remesher usually, well, I'm not going to say usually, a lot of times it can fail on more complex things, but on simpler stuff, it's very easy to turn things into quads. And if you're going to just create high polys from your mid poly, non-destructive mesh, or whatever you want to call that thing, there you go. That's what it is. It's a non-destructive mesh. But you can create like a mid poly and do things manually at the same time as well. It's just one of those little tricky things, right? Like it's more work, it's more labor intensive, but the non-destructive one is the way to go if possible. And yeah, so anyways, I think you get the idea. Like, we can sculpt on these now. We can actually use the sculpt layers add-on with multi-reses as well. Sometimes it loses vertices though, so it's a little sketchy sometimes, but that's more of a fault, I think, of Blender's underlying triangulation system than anything else. But for whatever the case, I think you get the idea, right? So now we have been working on this thing, and we forgot to turn symmetry on. If you have a symmetrical object, you can actually just symmetrize it. Boom. So there's always workarounds. There's always tricks. There's always cool little things that you can do. But you have to really spend time modeling in Blender. You have to figure this stuff out. It takes time, right? Like, you're not going to know all of this off the bat, especially when you're making things that are way more complex than this. But there's no point in wasting time trying to model from the start to create perfect topology. It doesn't always need to be that way. And so even if you were doing a subdivision mesh, there's a good odd chance you're going to use Booleans in that process in order to create that subdivision mesh. Like, trying to, especially when you're doing like concept design, I would say, like concept design, it's very useful to use these kinds of techniques, but you can go very destructive with it and use voxel remeshes and dynamic topology and sculpting just to come up with ideas, and then you retopo it. Hard surface retopo. Like character retopo, I think we understand. We can kind of like place polygons on the character, right? Hard surface is similar. You can place polygons on top of the surface, or you can create new objects around it and do booleans to kind of capture that same shape and then clean it up and move forward with it. So this is all this video is about. I just wanted to talk about this stuff because honestly, it's really hurts me sometimes when like people don't fully recognize maybe what artists are doing out there. Like, it's very easy to get stuck in a certain workflow, not explore your options and understand You know, especially when you're doing game models and you're being tasked with doing all kinds of stuff, especially if you're on an indie project. You might be doing characters or vehicles or hard surface elements or just straps around a handle or something like that. There's always techniques. Sometimes subdivision works better. Sometimes like modeling subdivision from the start works better. Sometimes doing the Booleans first. Sometimes doing both at the same time. It's something you really just have to practice with. And once you start recognizing these possibilities, you'll become a stronger artist because of it. Like whenever you watch these pros out there doing this kind of stuff, they don't think about it twice. They just use it, and they start hammering away at their models until they get the results they want. They're very fast at it too, because there's a lot of stuff to do a lot of times, but very deliberate with which kind of techniques they're using as well, because they've spent that time researching these different things to and playing around with them and learning them so that they can actually utilize them effectively. This here with the going to multi-res, I just want to preface this and warn you, for hard surface things, it's really hard to get a nice hard surface result out sometimes for that nice crisp fidelity that you might be looking for. ZBrush is the better option for that just because of the way it renders triangles over there. And but you can still do it in Blender. You just have to be methodical about it. So it's very challenging to get into that process anyways. But so sometimes smaller details like this, you might be better off doing it in Substance Painter is what I'm trying to say. Like if you can get the Painter to do that. Anyways, that's it for this video. I just wanted to talk about it real quick, and I hope you enjoyed. Check out the next one. All right. Take care.